Click for IB Biology. We're in the transport section of the syllabus and we're looking at the structure of arteries. And what we're going to do in this video is we're going to relate the structure of an artery to the functions of an artery. Now, should you wish, in the description there's a PDF of this presentation so that you can annotate your own notes, and there's also a quick quiz that you can take along with some channel links. So let's get into this. So arteries take blood away from the heart to the capillaries where exchange takes place. Nothing goes into or out of the blood in the arteries. No exchange takes place there. If we look across to the right-hand side, what we see is in this diagram where we've got blood pressure here and the particular blood vessel here. Notice that the blood pressure in the arteries remains relatively high during their journey to the capillaries where exchange takes place. The up and down nature of this is due to the lower part is what would be called the diastolic pressure, and the upper part would be called the systolic pressure. And of course this relates to the beating of the heart. So each one of these peaks here relates to the beating of the heart. But what we're trying to do is to understand why does the blood pressure remain fairly high despite the blood traveling a long way from the heart. To do that, we need to examine the structure of the artery itself. So the space down the center of an artery is called the lumen. That's where the blood passes through. And then the lumen has a layer on the inside which is called the tunica intima. And the tunica intima, on the inside, there's a tissue type called endothelium. That's on the inside, and the slight thickening around that is due to the presence of protein fibers made from a protein called elastin. And as the name suggests, they are elastic. The second layer of an artery is called the tunica media, and this is largely composed of smooth muscle. But once more, we have the presence of elastin between those muscle tissues. Around the outside of the artery is called the tunica externa, and the significance of this layer is the presence of collagen, which provides it with support and strength. So the tunica media has smooth muscle and elastin tissue, and the collagen tissue is in the external structure. So blood is leaving the heart and coming this way through the arterial system, and yet even when we get to faraway organ systems, the blood pressure is still high. How does this occur? Well, the emphasis has to be on the presence of the elastin tissue. Here we have the blood vessel in diastole, which is the lower reading. And here we have the blood vessel stretched out in systole, the higher reading, as a pulse of blood passes through. And this causes a stretching of the blood vessel, as we can see with the lumen size here. But remember the idea of the elastin. So as the pulse of blood goes through, there is a stretching. But then what occurs is that the elastin tissue, as the pulse passes, the elastin tissue causes a recoil much as an elastic band shortens when you remove the stretching force from it. And this recoil creates a pressure on the blood volume and sustains the pressure even though we're traveling a long way from the heart. So the collagen on the outside is creating the structural, giving it strength and structural support. The inner tissue, the media tissue, is giving it the stretch in the elastin tissue and creating this elastic, what's called elastic recoil of the tissue due to the elastin protein molecule. And that's why the blood pressure stays high all the way to the capillaries and the tissues where exchange takes place.